Hello everyone, I am Noor Zainab and I hope you all are doing well, and in today's video I am going to discuss about projectile motion. In previous videos we discussed about the equations of motion. Equations of motion are only applicable to the objects that move in one direction or one dimension. But today we are going to discuss a type of motion in which the objects move in two dimensions or two directions. And this type of motion is known as projectile motion. In this video, I will also discuss the derivation of height, range and time of a projectile, and at the end of this video, I will be discussing some important relations between height, range and time of the projectile. Let's suppose we have a ball and a force is applied on this ball. As a result, due to this force, the ball will move in this path. This path is known as a parabolic path, and this object which moves in this path is known as projectile. This type of motion is known as projectile motion, in which only one force is applied during the beginning of the motion and afterwards no force is applied, and the object moves only due to gravity. So we can also say that the object is moving in free fall motion only due to gravity. The path which is followed by this projectile is known as trajectory. How far this ball goes is known as the range of the projectile, and the maximum height which this ball goes is known as the height of the projectile. For how long this projectile remains in the air, or we can say that the time which is taken by the projectile to go from the point of projection to the point of impact is known as the time of flight of the projectile. And always remember that the acceleration along the x-axis is always 0 meters per second squared, whereas the acceleration along the y-axis is negative. As we know that projectile motion occurs in two dimensions, it is the vertical axis, which is the y-axis, and the horizontal axis, which is the x-axis. So we can say that the acceleration of the object has two components. One is the x component, which is always 0 because no force is acting along x-axis, whereas the vertical component of the acceleration is equals to the gravity, which is 9.8 meters per second squared. We are taking gravity as negative. This is because gravity acts downwards, and in a mathematical graph we can see that along y-axis the downward values are always negative. In this video, we will be discussing about ideal projectile motion. In ideal projectile motion, we neglect air resistance, wind speed, and the spin of the projectile. These factors influence the flight of the real-life projectile. So here we will only consider the ideal projectile motion in which the air resistance is neglected. Depending on the angle of projection, which is also known as launch angle, there are some types of projectile motion such as oblique projectile motion, horizontal projectile motion, and projectile motion on an inclined plane. In horizontal projectile motion, the object is thrown at any angle but from a certain height. Whereas in projectile motion on an inclined plane, the projectile lands on an incline. The path which is followed by this object or projectile is known as trajectory, and it has two components. One is the horizontal component and one is a vertical component. Both of these components are independent of each other. Here you can see the projectile motion of a ball. Height is taken along the y-axis, whereas the distance which is covered by the ball is taken along the x-axis. The maximum vertical distance reached by the projectile from the projection level is known as the maximum height of the projectile. The horizontal distance covered by the projectile from the point of projection to the point of impact is known as the range of the projectile. And the time taken by the projectile to go from the point of projection to the point of impact is known as time of flight. Here v0 is the initial velocity, and this initial velocity has two components. One is the horizontal component and one is the vertical component. And remember that this ball is moving only due to gravity. Now let's resolve the initial velocity into its horizontal as well as vertical components. So here now you can see a ball which is moving in projectile motion. This angle is known as the angle of projection. So now what we are going to do is that we will resolve this initial velocity into its horizontal as well as vertical components. So now we will draw a dotted line here. This shows us the vertical component of the velocity, whereas OQ shows us the horizontal component of the velocity. Here you can see that Vi represents the initial velocity, whereas Vix represents the horizontal component of the initial velocity, and Viy represents the vertical component of the initial velocity. So in order to find the exact values of the horizontal and vertical components, we're going to apply some trigonometric rules. As we know that cos theta is equals to base divided by hypotenuse, and if we find the base, we will have hypotenuse times cos theta. So in this way, if we put the values of base and hypotenuse, hypotenuse is the longest side, so it is Vi, and base is Vix. So in this way, we have the value of the horizontal component of the velocity. Now, in order to find the vertical component of the velocity, we will take sine theta. Here, sine theta represents perpendicular over hypotenuse. So we can see that the perpendicular is the initial velocity's y component. So by putting this value, we get these two equations. One is for the horizontal component and one is for the vertical component of the velocity. So here a question can arise that how can we know that in order to find the x component, we have to take cos theta, or in order to find the y component, we have to take sine theta. This is because this is our initial velocity. In order to find the x component, we have to take a trigonometric formula that has the base. This is the base of the triangle. So base is only present in cos theta, so we're using this formula. Now, if we have to find the perpendicular component of the triangle, so perpendicular component is only present in sine theta, so we are using this formula. So now we can also say that the angle of projection or launch angle is the angle between initial. So now we can also say that angle of projection or launch angle is the angle between initial velocity and the horizontal plane. In this way, we can resolve the velocity vector of the object into its horizontal and vertical components along the whole path of the projectile motion. So now you can see here that this is the initial velocity, and in green color you are seeing the horizontal component, and in pink color you are seeing the vertical component, and theta is the angle of projection. And we know that the acceleration which is acting along y-axis along the whole path of the projectile is negative g, which is the negative value of the gravity, whereas along x-axis no acceleration is produced. Now if we talk about velocity, along x-axis velocity is equals to v naught cos theta, whereas along y-axis the velocity is v naught sin theta, where v naught is the initial velocity. So if we summarize this whole thing along x direction and y direction, we can say that along x direction or the horizontal direction, acceleration is always zero. If acceleration is always zero, it means that velocity is not changing, because acceleration is a rate of change of velocity. So we can say that velocity remains constant and its value is equals to vi cos theta, where vi is the initial velocity. And now if we talk about the y-axis or the y direction or y dimension of the projectile motion, so we can say that along y direction, acceleration is constant and it is negative 9.8 meters per second square, whereas velocity along y-axis changes uniformly and it can be positive or negative depending on the direction of initial velocity. For example, we can see that when the object is launched, its initial velocity is vi and its vertical component is viy. After some time, when it reaches the height, the vertical component of the velocity becomes zero. It means there is no velocity along y-axis, whereas initial velocity is also there and the horizontal component of the velocity is also there. Gradually, the vertical component increases. So we can say that the vertical component of the velocity changes uniformly. When the object is going upwards, its value decreases and then increases gradually or uniformly. Hence, we can say that along x-axis, velocity is constant, as we can see here in green color, whereas along y-axis, velocity is changing uniformly, or there is a uniform change in velocity. So now let's discuss some of the types of the projectile motion. First of all, we're going to discuss about horizontal projectile motion. Projectile motion of an object which is launched horizontally from a certain height. When the object is launched from the height, it has a certain velocity, and this velocity is known as initial velocity. And this velocity is along the x direction or along the x-axis, whereas along y-axis there is no velocity. It means that the initial velocity Vix along the x-axis is equals to the initial velocity of the object, whereas along y-axis there is no velocity, so the velocity along y-axis is 0. So now if we plot a graph, we can see that when the object is moving, it comes down and it follows a parabolic pathway. It is a projectile motion because the object's velocity is in both horizontal as well as in vertical direction. Initially, when the object is on a height, the y component of the velocity is 0, but gradually when it comes down, the velocity component increases along y-axis, whereas the x component of the velocity remains constant. So we can say that the x component of the velocity remains constant and the y component increases gradually. And if we talk about acceleration in this case, the acceleration along the x-axis is always 0. No acceleration is produced along the horizontal component of the object, whereas along vertical axis, if we see that acceleration is equals to gravity. So now here you can ask that why we are taking gravity as positive. Remember always that when an object is moving downwards, the gravity or acceleration is taken positive. Whereas whenever an object is thrown upwards, the gravity or acceleration is taken negative. So here we are taking gravity as positive because the object is thrown downwards from a certain height. So now let's calculate the final velocity of the object. In order to calculate this, we know that the horizontal component of the velocity Vx is constant. It remains constant, same, whereas the vertical component of the velocity Vy increases gradually as we move downwards. So at any instant of time t, we can say that if the horizontal component of the velocity is Vfx, which is along the x-axis, and is always equals to Vix, which is the initial velocity, and it is equals to Vi cos theta. So we can find the final velocity of the object by using the first equation of motion, which is Vf is equals to Vi plus At. But we want to find the final velocity for y-axis. We have the value for x-axis, so we will put values for y-axis. So in this way, we will get this. The final velocity equals to initial velocity along y-axis, as we know that initially the object had velocity along x-axis. There was no velocity along y-axis, so the initial velocity along y-axis will be 0 and the acceleration along y-axis is gravity, and in this way we have the final velocity equals to gt at an instant of time t. And it is important to note that the initial velocity or the y component of the velocity is 0, then it increases linearly with time t. Here Vfy is the final velocity and t is the time, and it is increasing linearly. As we know that velocity is a vector quantity and vector quantities have both magnitude as well as direction. So the magnitude of the instantaneous velocity, it is at a particular time t. This is the magnitude of the instantaneous velocity and it is taken from the resultant of both the x components and the y component of the final velocity. Whereas direction of the instantaneous velocity is found by using this formula, and always remember that final velocities are taken, y component is taken in the numerator and the x component is taken in the denominator. and we have to take tan inverse of these values in order to find the direction of the velocity. So now if we calculate the distance which the object has traveled, the displacement which is covered by the object in time t. As we know that velocity equals distance divided by time, if we have to find the distance or displacement, we can multiply velocity with time t. And hence, putting the values of velocity, we will take final velocity along x-axis. And note that we are taking velocity along x-axis because along x-axis velocity is constant, whereas along y-axis it is increasing uniformly. And if we have to find the vertical displacement, we will use the second equation of motion, which is s is equals to vit plus half at square. And as we know that initially the velocity was 0, we will put the value of 0, and acceleration is taken as gravity. In this way, we can calculate the vertical displacement of the object. So now let's discuss the projectile motion of an object which is thrown at some angle from the horizontal, and this motion is known as oblique projectile motion. So here you can see a ball which is launched at an angle from the horizontal, and this ball covers a projectile motion, and this path is known as parabolic path. So here you can see that the angle between the initial velocity and the horizontal component is known as angle of projection. The horizontal component is taken as vi cos theta, whereas the vertical component is taken as vi sin theta. And you can also see the velocity vectors along their x components and y components are shown along the trajectory of the projectile. The acceleration along x-axis is 0, whereas along y-axis it is minus g, which is gravity. And velocity along x-axis remains constant, whereas along y-axis, when the object is moving upward, it decreases, and when it is coming downwards, the velocity along y-axis increases. And here vi is also known as the velocity of projection. So now if we have to calculate the final velocity of the object, and we are having the initial velocity and we have divided it into its horizontal as well as vertical components. We know that the horizontal component remains same, whereas the vertical component of the velocity is changing with time t. So as we know that initially the velocity along x-axis was given as vi cos theta, whereas the velocity along y-axis was given as vi sin theta. So at any instant of time, the final velocity along x-axis and y-axis. So now we have to find the horizontal as well as vertical component of the final velocity. So as we know that the horizontal component of the velocity remains constant or same, so the initial velocity is horizontal component as well as the final velocity is horizontal component remains same. So we can say that horizontal component of the velocity, which is the vfx final velocity, is equals to the initial velocity's horizontal component, and it is equals to vi cos theta. Whereas we have to find the vertical component. In order to find the vertical component, we will use the equation of motion, where final velocity equals to initial velocity. Initial velocity is taken as vi sin theta. Here we are taking acceleration as negative g, and t is the time taken for the motion. So in this way, we derived the final velocity components, horizontal as well as vertical. The horizontal component remains same or constant, whereas the vertical component changes, and its value can be found using this formula at any instant of time. And as velocity is a vector quantity, so in order to find the magnitude of the final velocity, we will take the resultant of the horizontal as well as vertical components of the final velocity. In this way, we will get the magnitude. In order to find direction, we will apply the formula of finding direction of final velocity along y-axis and final velocity along x-axis. In this way, if we put the values of the final components along x-axis and y-axis, we get these equations. So in this way, the magnitude as well as direction of the final velocity can be found. So now let's derive the horizontal displacement or the distance which is covered by the object. So now as we are discussing the horizontal components, we know that horizontally the velocity remains constant. We can derive the displacement by using the formula distance is equals to velocity into time t. Here we are taking final velocity, as we know that final velocity along x-axis is equals to the initial velocity's x-axis component, and it is equals to vi cos theta. So in this way we can say that the horizontal components of the final velocity as well as initial velocity remains constant. So we can put this in this formula, and in this way we get the horizontal displacement. And now let's find the vertical displacement of this object. This can be found using the equation of motion. S is equals to VIT plus half AT square. Instead of S, we're writing Y, which is a vertical component. VIT is the vertical component of the initial velocity. Remember, here we are taking initial velocity, not the final velocity. And instead of acceleration along y-axis, we are taking negative g. So remember to replace this positive sign by the negative sign. In this way, we're getting the formula to find the vertical displacement of the object. So simply by putting the values in the equation of motion, we're getting the vertical displacements formula. Only in vi along y-axis we put its value, and we discussed its value in the previous slides, that along y-axis VIY is always equals to VI sin theta, and along VIX is equals to VI cos theta. Now let's discuss that how we can find the maximum height of the projectile. Maximum height is the maximum vertical distance which is covered by the object from the level of projection, and it can be calculated using third equation of motion. So consider a projectile which is thrown with a certain angle theta with a certain initial velocity vi. To find the maximum height of this projectile, we will be using third equation of motion. But remember, to find the maximum height along y-axis, we will use the third equation of motion only along the y-axis. So here, acceleration along y-axis is taken, and the displacement along y-axis is replaced with h. So here, by replacing all these values, we can see that the final velocity of the object is 0 along y-axis, whereas the initial velocity of the object along y-axis is given as vi sin theta, and the acceleration along y-axis is always negative g, and the height is taken as h. So by replacing all these values in the above equation, we get this, and by rearranging and by cutting, we get the formula to find the height h. So in order to find the height of the projectile, what you have to do is simply apply the third equation of motion along y-axis and put the values. Now let's discuss the time of flight or time of projectile. And in order to find the time of projectile, we will be using the second equation of motion, again only along the y-axis. The time which is taken by the object to go from the point of projection to the point of impact is known as the time of the projectile. So here we can replace the values, as we know that along y-axis or the vertical axis, the displacement is the height h, and it is always 0. Why we are taking displacement along y-axis as 0? This is because we are taking displacement or the height h along y-axis as 0. So in this diagram, if we label the points as P and Q, first the object was here. So here you can see that initially the object was here, and after following this whole path, the object came here in its final position. The initial position can be named as P, and if we name the final position as Q, we can see that before it was along x-axis. After following this whole path, again it is at the same axis, which is the x-axis. So the displacement which is covered by the object is 0. You can see that the object has traveled horizontally, that it has moved, it has displaced, but along vertically it has not moved. Only the object has made displacement along the x-axis. So along y-axis, we can say that the displacement along y-axis is 0. We can see that initially here is the point for the y-axis, and again it is at the same point, which is at the 0 level. But along y-axis, for y-axis displacement, we can see that initially the object was here at point P, and again at after some time t, it is again at the same position, so the displacement covered along y-axis is 0. But instead, if we see along x-axis, we can see that if the point initially was along 0, after some time t, we can say that the displacement has increased to, let's suppose, 100 meters. So we can say that along x-axis the displacement has been covered, whereas along y-axis the displacement is not covered, that initially it was 0, now again initially it is 0. And always remember that if the starting and the ending position of an object are same, the displacement is always 0. Although distance is covered, but the displacement is 0. As we can say that along y-axis distance is covered, but the displacement is 0 because the position is same. So in this way, we can take the vertical displacement of the object as 0. The vertical component of the displacement is 0, whereas the acceleration along the y-axis is taken as negative g. The time which is taken for the projectile to complete this projectile motion is known as time of flight or time of projectile motion. And VIY is the initial velocity along the y-axis, and its value is VI sine theta. By putting all these values in the above equation of motion, and here always remember to change the sign of g. G is taken as negative. And by rearranging all these equations, we get our time of projectile, which is equals to 2 VI sine theta divided by g. So simply to find the time of projectile, we have to use second equation of motion. In second equation of motion, only along y-axis, and by putting all these values in the equation, we will get our time of projectile. Always remember that along the y-axis the displacement is 0, so in this way we will calculate the time of projectile. The time to reach the summit, or which is the height of the projectile motion, it will be the half of this time, and it is also known as the time of summit or summit time, or the time to reach height. We will divide this time by 2, and in this way both of these 2's will be cancelled, and this will be the summit time, the time to reach the summit or the height of the projectile motion. Let's calculate the range of a projectile. The horizontal distance from the point of projection to the point of impact is known as the range of the projectile. And in order to find the range of a projectile, we will be using this equation, but only along the x-axis because the range is taken along x-axis. So velocity will also be taken along x-axis, and by putting the value of velocity along x-axis, which is vi cos theta, and we will be taking time as the time of projectile, and by putting these values we will be getting this equation, and this is the formula to find the range of a projectile. And range is the point of impact where the projectile will be landed, or we can say how far the projectile will go. We can calculate these things by finding the range. This equation shows us that the range depends on two things. One is the angle theta, which is the angle of projection, and the second thing is the initial velocity. So if we increase initial velocity, the range will be increased, or if we increase the angle theta or the angle of projection, the range will be increased. Now, what should be the value of the angle theta or the angle of projection so that the maximum range is produced? Let's calculate. As we know that range is equals to vi squared sine 2 theta divided by g, as we have calculated right now. In order to produce maximum range, this side of the equation should be maximum. It is sine 2 theta must be maximum, and sine 2 theta is only maximum when it is equals to 1. In this way, the range will be maximum. Sine 2 theta must be equals to 1. So we can bring sine on the opposite side. In this way, sine will become sine inverse. As we know that sine inverse is equals to 90 degree. So 90 into 1 is 90. So in this way, 2 theta maximum is equals to 90 degree. If we bring 2 on the opposite side, or we can say dividing 2 with both the sides, we get theta is equals to 45. So this is the angle which produces maximum range. If we put angle theta as 45 degrees, maximum range will be produced. This means that the object will go very far from the point of projection. Two angles can also produce a same range. It means that two angles can produce if an object is thrown at two different angles, it can land on the same point or the same range. It only happens when the two angles are complementary to each other or their sum is equals to 90 degree. So such as 75 and 15, both of these are complementary angles. It means both when they are added, the result is 90. So if we calculate the range at both of these angles, such as range at 75 degrees is equals to Vi squared divided by G sine 275. When we calculate this portion, we get sine 150 and sine 150 is equals to 0.5. Same for this, we can calculate and we can see that the range at both of these two angles is same. It means that when an object is projected at 75 degrees, it lands on the same range, and when it projected at 15 degrees, it is landed at the same range. Hence, the range at 75 and 15 degree is same, but only same range is produced when both the angles add up to 90 degree. As now we have discussed that angle 45 degrees produces the maximum range. What is the maximum range? What is the value of the maximum range? As we have discussed, this is the formula to find the range, and if we are calculating maximum range, we have to put theta as 45 degrees. If theta is 45 degrees, then 2 theta becomes 90 and sine 2 theta becomes 1. So if this portion is 1, then maximum range will be produced. So this is the formula to get maximum range. So now let's discuss some of the most important relations. First of all, what is the relation between height and range? Height is the vertical component, whereas range is the horizontal component. So height is equals to 1 by 4 into range times tan theta, where theta is the angle and r is the range. So height is 1 by 4 times smaller than range times tan theta. Whenever angle theta is 45 degrees, we know maximum range is produced. So we can say that height is equals to 1 by 4 times of maximum range. If the range is maximum, height becomes 1 by 4th of the range. However, when theta or the angle of projection is 76 degrees, height and range become equal to each other. So we can say that at 76 degrees, height and range are equal to each other. Height and time of flight are related as height is equals to 1 by 8 gravity times t square, where t is the time of flight. And the relation between range and the time of flight is here. So in this video, we discussed all these topics. The projectile motion of an object which is launched horizontally, when an object is launched at some angle with the horizontal, and we also discussed how the time of projectile is derived, how the range is derived, and how the height of the projectile is derived.